Hi.
Hey.
So thanks for accepting to do an interview. You're actually our first micro interview for the day. So please do tell us who you are, what you do, and what's up.
Sure. Okay. I'm Stephen Cleary, and I do a lot of open source libraries. I'm a little addicted to it, so I also have developed a few tools around helping people do open source .NET libraries, since that's what I do a lot of myself.
Excellent. So what's a good example of a library that you develop?
Right, well, my most famous one is definitely called AsyncEx.
Okay.
And that provides things like an async context if you want to run code, asynchronous code synchronously with a nested loop. It also provides asynchronous synchronization primitives. So all the things that are like on Stephen Tobe's blog, he's got a series on how those work, and I just essentially wrote my own implementations and put them in open source.
Okay, so what problems does it solve that aren't already solved with async await? Is there stuff around enumerables or stuff like that?
Not so much with streams or enumerables, but like a lot of people run into a problem using locks, and the modern framework is 4.6 and newer, as well as .NET Core, has Semaphore Slim, which is a built-in replacement that you can use as an asynchronous compatible lock. But the usage is a little bit awkward. You don't get the using statement with it. So I have like a full suite of everything from async monitor, async semaphore, async lock, async producer consumer queues, things like that.
Okay, so anytime somebody needs to have some more advanced scenarios, they should check the library out and see if there is something in there that would help.
That's probably the most common use cases when people are taking existing threading code that blocks and uses some of these primitives like a reader writer lock, or that was actually a bad example, but like a manual reset event or something like that. Well, and they want to do an asynchronous equivalent, and that kind of stuff isn't built in to the framework yet. Anyway.
What do you think about what's going on with other languages in the way they handle asynchrony and concurrency?
Well, yeah, that's a good question, because you see, like, async, really started in Microsoft. It was a great innovation, and then now you see other languages picking it up. I mean, it's officially in Python. It's almost in JavaScript.
Yeah.
Some very major players are coming onto the board with async and await. And I think that the reason for that is because, first off, Microsoft did a great job designing the language feature, fitting it in with the existing language, thinking a lot about how it would work. And I think the reason people are adopting it so much right now is because async gives you two benefits. Well, actually, they're the same benefit underneath, because async is all about giving up threads. It's yielding threads, using fewer threading resources. And on client-side code, that's useful because you don't want to use up the UI thread. So you want to free up that UI thread. So async on the client side gives you responsiveness. And on the server side, the fewer threading resources you can use, the faster you can scale, the further you can scale. So async on the server side gives you scalability. And both of these are becoming a lot more important because we're seeing a lot more mobile use, where UIs have to be responsive. We're seeing a lot more cloud use, where it's cheaper to have a more scalable server. So more and more we're seeing async used, I think, because of the whole mobile first, cloud first development paradigm.
What about actually making concurrent programming a lot easier than it used to be? I mean, if you look back 15 years ago, we were using mutexes and horrors like that, and you still need them occasionally, but now you can pretty much start something that is asynchronous or concurrent without having necessarily to know about all those more complex concepts.
Yeah, you've got some great. Async gives you a great abstraction there, whereas before, I mean, if you wanted to write asynchronous code, it was entirely possible to do before, but almost no one actually did it because it was so painful. So async and await is
dangerous too. and dangerous. Dangerous.
Dan-
There is danger is doing that. You can.
Oh, dangerous! Yes.
Yeah.
Yeah, it is. Yeah, it's difficult. It mangles up all the code, spreads your logic out all over. It's, yeah.
Yeah.
Async and await really makes it a lot easier. So,
What about approaches that are actually kind of a little different, such as what Go is doing with channels? Do you think there is a benefit in having that in C# and .NET as well?
I don't know if it's possible, to be honest. What Go did with their Go routines is, and to a lesser extent, what JavaScript is now doing with with their, I forget what they're called, but essentially other threads, and that is that they, think of the web workers. What JavaScript's doing with the web workers, and what Go is doing with the Go routines, what they've been able to do is just say, well, you can't share memory. There's no memory sharing allowed.
Yep.
It's all message passing, all asynchronous.
Yep.
And so, because they're starting from that point, they have the ability to make it even easier to write proper asynchronous message passing code. C#, I don't know if we can ever actually get there, because in order to do that safely, we'd have to say you can never share memory among threads again, which is very difficult to say correctly.
Oh, you think it's all or nothing? Because there are some experiments, right? There is a GitHub repository where Stephen Cleary is contributing and a few other people, where there is an implementation of channels for .NET.
Yes, I'm not sure if that's quite the same thing though.
Probably not.
I mean, yeah, channels. Okay, so I see channels as kind of like a Dataflow Lite. There's the old TPL Dataflow library, which is extremely powerful, and a lot of people aren't
Great
aware
library,
of it.
by the way.
It kind of merges asynchrony and parallelism
Yep.
in a great way. And I think channels are kind of the way of getting TPL Dataflow in a slightly more modern form into like a .NET Core situation, which Dataflow does not currently support. But to say that that's going to be just as easy as Go routines or as safe as JavaScript web workers, I'm not sure. I don't know. I haven't played around with it enough to know.
Okay. Cool. Are there any other projects that you'd like to talk about?
Yeah, just one. I've been recently trying to do fewer libraries since, I don't know, I'm like at 40 or something right now.
Wow.
So, yeah. So I'm trying to do fewer libraries and more like applications. So I've got like .NET APIs, which was my first one. Wasn't, it's closed source. It's not great. It just goes over the NuGet packages and shows you like automatically generated reference API documentation. But the one that I'm working on now is fully open source right from the beginning. You can go on GitHub under Stephen Cleary apps, and it's called Net Standard Types. And what I'm trying to do there is to, again, use the NuGet feed and go and look at any .NET Standard compatible libraries, pull out all the types, and provide a good type search across the entire NuGet ecosystem for Net Standard types. So I'm using Azure Functions, which I've never used before. I'm using Azure Search, which I've never used before. So so join and watch me struggle.
Excellent. Well, thanks a lot. We'll put links to your repositories in the description for this video.
Okay.
And well, it's been great meeting you and chatting with you.
Yeah, likewise. Thank you.
Bye. Bye.